So when it's asking us about an odd function or an even function, all we have to do is look at the degree, your highest exponent, and determine whether it's an odd number or an even number. So for instance, if we had x cubed plus 4x squared minus 7, this is an odd function because your degree there, 3, is an odd number. That's all you have to do is look at that highest exponent, the greatest exponent, and determine is that an even number or an odd number. What this does is tell us the shape. An odd function is going to snake here, snakes up to the right, or it snakes down to the left, or down to the right, sorry. And whether or not it goes up to the right or down to the left, down to the right, is determined by whether or not it's a positive or a negative leading coefficient. Okay, so you can see it says leading coefficient is positive, then it goes up to the right, which reminds me of a linear function. This is a positive slope, and then a linear function with a negative slope goes down to the left. And so these kind of mirror that. Odd functions have their tails going in opposite directions. So everybody put your right hand up and your left hand down like this. Bend your elbow. Everybody do it. If everybody does it, then none of us look stupid. Okay, there we go. All right, your right hand's up and your left hand's down. You look like me. All right, and I am going down to the right. Am I not here? Okay, so this is an odd function because your arms are going in different directions. One's going up and one's going down. This is odd, and it happens to be negative because if you follow it, then it goes down. Now flip your arms. This is still an odd function. It means that my greatest exponent is an odd number, so 1, 3, 5, 7, 9. But it's positive because it's going up. Okay? Let your arms rest. Now put them both up. This is an even function. Your exponents are 2, 4, 6, 8. So the tails do the same thing. So they're both up or they're both down. Like one. Kind of like a parabola, right? If you have a positive number in front, your parabola opens up. And if you have a negative leading coefficient, then your parabola opens down. So the way that I think about this, odd, opposite. So if it's an odd function, the ends are doing opposite things or in opposite directions. Okay? So we're going to keep looking back on this when we have to graph and determine what the shape is. Okay. When you turn to 31, when you go to page 31, you see these here. These 4 steps will get you through every problem. These steps will allow you to graph everything. Step number 1, we're going to find our roots. And that may mean that we have to factor. Sometimes it will be factored for you, and sometimes you'll have to factor yourself. If you look at this example number 1, it's not factored yet, so we are going to have to do that. After we plot the intercepts, then we're going to do the y-intercept. Then we're going to talk about behavior. Then we have to do a table of values. So, you can look at those steps as we go through, and we're going to do number 1 here. All right. What is the best way to factor this? Or what do you want to try? We don't know if it'll work, but we can try it. How many terms are there? There are 4 terms, and how are we going to factor something with 4 terms? Grouping. Excellent. So, I'm going to group the first 2 and group the second 2. And then we look at that first group, and this is step number 1. We should label our steps here to organize. Step number 1, we're going to find our roots. So, what is the GCF here in this first group? negative x. And what's left over in parentheses if you factor or divide each of these by a negative x? Sorry, this is negative x squared. My bad. X plus 5. Good. If you divide by a negative number, then we're going to get a positive, which is good because I look over here and I see that my common factor is a 4 and my leftovers are x plus 5. And now they match. So each of these terms has an x plus 5. And when I divide that away from each of these terms, I'm left with negative x squared plus 4. Now the first one is ready to solve here. What does x equal?
Negative 5.
Good. This one needs a little more work. X squared and 4 are both squares. And there is a negative sign. So as long as there's one negative sign, it's actually a difference of squares. And the commutative property says it would be okay if I switched their order. So I'm just rewriting this factor with the 4 first and then the negative x squared. And now I have a difference of squares. So I take the square root of 4 and I make that a 2. And the square root of x squared is x. And we put a plus and a minus. And what does x equal here then? In this first one? Good. What about the second one? And there are your 3 roots. And now we actually graph those. So I put my first root on negative 5, then negative 2, then 2. So that's step number 1. Now on the homework, the first one is already factored for you. They give it to you in factored form. So all of this, you would get to skip all of this. Okay? Because they give this to you or whatever. Sometimes you have to do that part yourself. Step number 2, because what we're trying to do is just get as many points as possible for this function so that we can find all the curves. So step number 2 would be to find the y-intercept. So label it y-intercept. Definition is it's the point where the line or curve crosses the y-axis where x is equal to, good, x is 0 whenever you have a y-intercept. So, if this is my function, minus 5 x squared plus 4x plus 20. And if I substitute a 0 here and here and here, what happens to all of these terms? They cancel to 0, and what am I left with? Just a 20. Good. So we have to now graph 0, 20, which does not fit awesomely on my graph here. I need some more room. So, we're going to be off the graph a little bit here. Let me see, I have a negative 5, a negative 2, and a 2. Now I have 0, 20. I'm going to put that all the way up there. So I factor to get the roots, just put a 0 in to get my intercept. Now, step number 3, discuss the end behavior here. So you have 2 decisions you have to make. This is either an even or an odd function. So So let's look at the highest exponent. Your greatest exponent is 3.
That's what I said.
And is the number 3 an even number or an odd number?
Odd.
Good. So that means that this is an odd function. And it's either a positive function or it's a negative function. So you have to go look at your leading coefficient. So we're asking you to look in the very front. Is it positive or negative?
Negative.
Negative. Good. So if you look on page 30, we have a negative odd. Negative odd. So it's going to come down from the left and curve around. So the general shape is going to look like this. Okay, so when I go to connect all the points that I put on there, because you're going to notice the points look like a hot mess. They don't look organized at all. But then when you realize that they have to be this shape, it'll be easier to connect them. Okay? So we do need a few more because I don't know where this minimum or this maximum here should be. So we have to pick a few more points. And that is step 4, which is a table. And so we make an XY table. And this is our last step before we actually graph everything. So what we have to do is look here. I have values for -3, -2, and 2, because those are my zeros. I need the values for everything in between. So, what numbers are between your roots? Let's start here. What's between these two? -4 and -3. What's between the other two? -1, 0, and 1. Good. So these numbers, in case you're wondering where we got these are from between your roots. Okay, so this is a table for between the roots. And that's going to help us figure out how far up and how far down my curves are supposed to go. Now, I already have the 0. What was it? When I substitute a 0 in, I get 20, right? That was our y-intercept. So now I do have to do the work for all of these. So, we need to go up here. And we have to put a -4 in for those x's. I know. And if you're going to use a calculator, like I know many of you are going to do, you have to be careful with the negatives. All right. This function starts with a negative sign, so you put that there. And then you're going to take -4 and cube that. So in parentheses, we need to have -4 cubed. Oops. So I put the -4 in parentheses and the fact that it's cubed in parentheses. What is -4 cubed? That's -4 times -4 times -4. -64. Good. But if you put a negative in front of the negative, what will you end up having? +64. Good. And then it was minus 5 times -4 cubed. Nope, squared, right? And that's -16 plus 4 times -4 squared. It was minus, wasn't it? -4. Okay. Let's write it. I had 64 minus 80. What's 64 minus 80? 64 minus 80, negative 16 minus another 16, negative 32 plus 20. Good. So we need to plot -4, -12. So -4, -12, right here-ish. I wrote too close to the graph. So now I put -3 in. What is -3 cubed? -27, but you have to make the negative negative. Good, that's 27. What's -3 squared? 9 minus times -5. That's -45. Good. 4 times -3. Plus 20. So that's -18 minus 12 is -30. Plus 20 is -10. So we plot -3, -10. Now I substitute in a -1. -1 cubed minus a negative. Yep. So it has this negative sign in front of the negative number. What's -5 times 1? -5. 4 times -1. And then plus 20. So what's 1 minus 5? Minus 4 plus 20. Good. So we have -1, 12. -1, 12. So here's where the graph's going to start to look like. You're going to come down. You're going to come down here. You're going to go back up. And then you're going to come back down. Okay? So very steep curves. Now we just have to put a +1 in and we'll be done. 1 cubed is 1, but this negative sign in front makes it negative. 1 squared is 1 times the -5. 4 times 1 is 4, and then plus 20. So this is -6 plus 4, -2 plus 20 is 18. So we will graph or plot 1, 18. So, when we did this, step 3, we decided it was going to come down from the left and curve up. So we have to come down from the left when we connect these. So, we have to. Really bad connecting. Here we go. It's going to come down from this, hit this. Told you, I didn't even get through the points. It needs to come down, go through this. We're supposed to go through this, like that.
Well, it's
Quite the curve, isn't it? Because of that plus 20 there at the end. So what we're going to do, that was example 1. We're going to do the first one on this assignment together. You're going to cross number 4 out. Number 4 cannot be done any way that we know how. So we are not responsible for number 4. So cross out number 4.
Is this homework?
It will be, yes. So we are not doing number 4. Cross that out. And we're going to do number 1 together. Exactly. You're only going to be responsible for number 2 and 3 then tonight. All right. So it looks like this. What do you notice about number 1? Why is number 1 a little nicer than the one we just did? They factored it for you. So we didn't have to factor by grouping or do the P's and Q's with synthetic division. It's just factored for you. So our step number 1, to find the roots, all we have to do is look at these factors that we have here. So, what would x equal here? Huh?
2. Negative.
Negative 2, good. What would x equal here? 3. Now, do you see that x plus 2 is raised to the 2nd power? Okay. I want you to look, and we touched upon this very lightly on another day. Go to page 28 here. The middle square over here. When a factor is raised to an odd power, the graph crosses the x-axis. So when I graph this, the fact that x minus 3 was raised to the 1st power, that is odd. That means that the line is actually going to cross the x-axis at 3. But the 2, x plus 2, is raised to an even number. And this says when a factor is raised to an even power, to the 4th, to the 6th, to the 8th, the graph just touches the x-axis, which when I'm graphing, I usually say it bounces. Okay, it just touches or bounces. So I'm going to make a note to myself here that when I actually draw the curve, when I come down to the negative 2, I'm just bouncing off of that and going back. And it's all about the exponents because there were 2, 4, 6, 8. You bounce off of it. Okay, so there were 2 of them. All right, step number 2, we got to find our y-intercept. So that means you put a 0 in for x, put a 0 in for x, then we have to solve for the y. So if you put a 0, what's 0 plus 2? Squared? Good. And then 0 minus 3? Awesome. So y is negative 12. So that's another point that we can graph. We can plot 0, -12. Kind of where we think it would go. All right. Step number 3. This is where you make decisions about being even and odd, positive and negative. How many total exponents do you have, even if you don't even see them together? Look at the original function up here. I have 2 of these and 1 of these. 3. Good. So there are 3 here. And so is that even or odd? Good. The number 3 is odd. And then in front, do you see a negative sign anywhere in front?
No.
No. So that's a positive function. So when you look, we know that odds are the ones that snake around like this. But because it's positive, I need to work my way up. Positive means up to the right. So eventually, when I am ready to connect my points, I'm going to make them in this shape here because it's positive. So I have to start going up. Last part. Table of values. Table of values. What values or x values are between our roots? So let's take a look at our x-intercepts. What numbers are between my 2 points there? Good. -1, 0, 1. What did I miss? And 2. Thank you very much. Awesome. Remember that the function is x plus 2 squared times x minus 3. So I'm going to put a -1 into both of these. What is -1 plus 2 squared? What's -1 minus 3? Did I do that right? Yeah. So what's 1 times -4? -4. So that ordered pair is -1, -4. And so we go up here and we graph -1, -4. And then we have to put, we already put a 0 in. What did we get? -12? Okay, so we don't have to do that. And I already plotted that one. If you don't have it yet, put it on there. Okay, now we're going to substitute in a 1. What is 1 plus 2 squared? Good. And then 1 minus 3 for a total of -18. So we get 1, comma, -18. So that's kind of a problem there. 1, -18, probably at least down there somewhere. And then a 2. What is 2 plus 2 squared? And 2 minus 3? So 16 times -1. Good. And that's our last point. So now we plot 2, -16. I assume it's like kind of down by 18. All right. So you look at that, and if you look at it from a distance, you're like, that doesn't look like a graph or a curve at all. So that's where it's important that you understand that you're trying to make a shape that looks like this out of that. So I'm going to start with my leftist point, and I know that I need to go up and up. So I also need to know, by the way, super important as I do this, what is happening at the -2? It's bouncing off. It's not going to go through it. So I'm going to take this. And we're going to come up here. We're going to bounce off the -2. We're going to curve down like this. And go like that. Okay? So all I know is I have to connect my points. So this was the leftist. So I know it bounces off of that, which means it was coming from down here, bounced off. This is the next point. That's the next left. Then we go up. And then I have to hit that. And that's it. So your only responsibility is to do 2, like that color, and 3. And that's it. And I would